Betelgeuse, a Goliath-red supergiant star arranged inside the Orion constellation, is a divine miracle that has interested both researchers and stargazers for a long time. If placed at the core of our solar system, its monstrous size would extend beyond the orbit of Jupiter, making our Sun appear small in comparison. This tremendous star is not just colossal in size, but also undergoing significant changes that may trigger a phenomenal, devastating event. Experts, including the notable scientist Brian Cox, have raised concerns as Betelgeuse has been sending disturbing signals across space. These changes have prompted a pivotal question. Will we witness an explosive event that could alter the night sky forever? The mystery surrounding Betelgeuse is captivating, as stars are born, live, and die in ways that challenge our understanding. As a red supergiant, Betelgeuse resides at the outer reaches of our galaxy and has become a key focus of study for astronomers. Its massive size, ancient age, and fluctuating red color, along with its changing brightness, have fascinated both scientists and casual observers for centuries. While its color shifts and brightness variations have been studied for a long time, recent developments have raised even more pressing questions about its future. Now, as it approaches the end of its life cycle, Betelgeuse's immense size, about 700 times larger than the Sun, indicates that it is nearing its final stages. To grasp the scale, if Betelgeuse were to replace the Sun, its outer layers would extend past Mars, engulfing Mercury, Venus, Earth, and Mars in the process. This tremendous size not only reflects the star's current state, but also reveals its stage in the stellar evolution process. Having consumed the hydrogen at its core, Betelgeuse is now expanding and cooling, a clear indicator that it is heading toward its inevitable demise. Betelgeuse is estimated to be around 8 to 8.5 million years old, which, while relatively young by human standards, is quite old compared to most stars. Over millions of years, it has undergone drastic changes, evolving from a hot blue star into the red supergiant we see today. The evolution of stars like Betelgeuse is driven by the ongoing balance between nuclear fusion at the star's core and gravitational forces that influence its expansion and contraction over time. The red color of Betelgeuse signifies its cooler surface temperature compared to younger stars like the Sun. While the Sun's surface temperature is around 5,500 Kelvin, Betelgeuse's is much cooler, about 3,500 Kelvin. This cooler temperature causes the star to emit light at longer wavelengths, giving it its distinctive red appearance. However, this color change is not merely cosmetic. It provides crucial insights into the star's internal processes and ongoing evolution. Records from ancient civilizations, including the Romans and the Chinese, described Betelgeuse as yellow. It was only in the 9th century that Arabic astronomers first documented its shift to red. This color change is a direct reflection of the star's evolution, marking its transition from a younger, hotter star to the cooler red giant it is today. Furthermore, Betelgeuse is a variable star, meaning its brightness changes over time. These fluctuations, both short-term, lasting days, and long-term, spanning years, have been closely observed for centuries. The renowned astronomer Sir John Herschel documented these variations as early as 1836. Unlike many other stars with predictable brightness patterns, Betelgeuse sometimes exhibits unexpected deviations, suggesting the presence of complex, not yet fully understood processes within the star. In 2019, astronomers observed a sudden and dramatic dimming of Betelgeuse, an event that became known as the Great Dimming. This surprising occurrence sparked widespread debate among scientists. The star's brightness decreased at an unprecedented rate, losing 0.01 magnitudes per day. By February 2020, Betelgeuse had reached one of its dimmest states in recorded history. This was particularly significant because Betelgeuse is typically one of the brightest stars in the night sky and can even be seen from Earth's most light-polluted areas. The sudden dimming was noticeable to casual skywatchers, leading to questions about what could be causing such extraordinary changes. One of the challenges in studying Betelgeuse is the time delay inherent in observing it. Light takes hundreds of years to travel vast distances, so when we observe Betelgeuse, we are actually seeing it as it was 725 years ago, not as it is today. This delay makes it difficult for astronomers to track rapid changes in real time, complicating efforts to predict or fully understand the reasons behind these fluctuations. During the 2019 to 2020 dimming event, astronomers like Andrea Dupree, deputy director of the Center for Astrophysics at Harvard and the Smithsonian, closely monitored the star's behavior using the Hubble Space Telescope. These observations provided crucial information about the inner workings of a variable star like Betelgeuse, revealing massive changes in its outer atmosphere. Spectroscopic analysis from Hubble indicated that material was being ejected from the star's surface at speeds of up to 200,000 miles per hour, forming a dust cloud that partially obscured the star's light, contributing to the dimming. This rapid mass loss was particularly striking, as it occurred at a rate far higher than the Sun's typical mass loss. The intense ejection of material led to speculation that it could be an early sign of a far more dramatic cosmic event, such as a supernova. The big question that arises is whether the unusual dimming of Betelgeuse is a precursor to a supernova, an explosive death of a star. If Betelgeuse were to explode, the event would release an enormous burst of light, potentially making it visible from Earth even during the daytime. This explosion would outshine the full moon, providing scientists with a rare and valuable opportunity to study the final moments of a massive star's life. Despite the dramatic nature of a supernova, Betelgeuse's distance from Earth, around 725 light-years, ensures that such an event would not pose a direct threat to us. Several theories have been proposed to explain the rapid dimming of Betelgeuse. 1. One widely accepted hypothesis suggests that the dimming marks the early stages of Betelgeuse's transition into a supernova. 2. Another theory proposes that a dust cloud is blocking our view of the star, as red supergiants like Betelgeuse frequently shed material throughout their lives. 3. A third possibility is that changes in the star's outer layers, photosphere, are responsible for the dimming. Spectroscopic data indicated a drop in Betelgeuse's surface temperature by about 170 Kelvin, which could suggest the presence of a large dark spot on the star's surface. Regardless of the cause of Betelgeuse's dimming, its future remains a critical area of study for astronomers. The future of Betelgeuse remains a critical area of study for astronomers. Red supergiants like Betelgeuse play a vital role in our understanding of stellar evolution. These stars represent the final stage in the life of a massive star before it explodes in a supernova. Their enormous size and relatively short lifespans make them ideal subjects for studying the processes that lead to a star's death. Additionally, the energy released during their final stages is essential for the creation of heavy elements, which serve as the building blocks for planets and life as we know it. If Betelgeuse were to explode in a supernova, it would provide an unprecedented opportunity to study such a cataclysmic event up close. Supernovae are responsible for dispersing heavy elements throughout space, enriching the interstellar medium and influencing the formation of new stars and planets. Astronomers continue to monitor Betelgeuse closely, using advanced telescopes such as Hubble, James Webb, and ground-based observatories. New observations will help determine whether the star is indeed approaching a supernova explosion or if its recent dimming was simply a temporary phase in its natural cycle. One thing is certain: Betelgeuse's fate will remain a subject of great fascination for scientists and stargazers alike. Whether it explodes within our lifetime or continues to evolve for thousands of years, this colossal star holds invaluable clues about the life and death of massive stars, helping us unravel the mysteries of the cosmos. Medium and adding to the development of new stars, planets, and possibly life, insect juices, an inevitable cosmic explosion could essentially affect our comprehension of these vast cycles. What's more, it could give a dynamite show to skywatchers. Albeit the blast would not represent a threat to Earth, it would nonetheless have significant ramifications for how we might interpret the universe. The investigation of Betelgeuse's diminishing and its eventual death will continue to give significant insights into the life cycles of stars and the more extensive grandiose cycle. Red supergiants like Betelgeuse are critical for understanding the advancement of the universe. Their touchy passings assist with shaping what's to come of systems, stars, and planets. As space experts continue to observe Betelgeuse's change, the lessons gained from this famous star will undoubtedly add to our more extensive comprehension of heavenly development. Through the investigation of red supergiants and their possible destinies, researchers are acquiring key experiences into the existence cycle of gigantic stars. In spite of their more limited life expectancies compared to more modest stars like the Sun, these colossal stars play an essential role in grasping how stars are conceived, advance, and eventually die. Acquiring a more profound comprehension of the processes that lead to a star's sensational end, for example, a cosmic explosion, permits researchers to make more exact forecasts about different stars in comparable phases of development. Fashioned within its center, all through space, these elements, including iron, carbon, and oxygen, are essential for the development of new stars, planets, and possibly even life. The blast of Betelgeuse, assuming it happens, would add to this vast cycle, improving the interstellar medium with fundamental components that could become part of new star systems. Supernovae, moreover, significantly affect their environmental factors. The shock waves from a cosmic explosion can pack close by gas mists, setting off the development of new stars, while the radiation delivered in the blast can impact the chemical composition of these new stars and planets. Understanding how supernovae work can give valuable insights into the pattern of star birth and death, adding to our knowledge of the universe's evolution. As Betelgeuse continues to evolve and shows strange behavior, space experts will likely increase their observations, utilizing tools like the Hubble Space Telescope. These observations will provide critical, continuous data on the star's activities, assisting researchers with refining their models of heavenly development. By studying Betelgeuse, stargazers will gain a deeper understanding of how huge stars like it live and die, and how these cycles shape the larger universe. The investigation of red supergiants like Betelgeuse also educates our understanding of more extensive grandiose forces, including the formation of galaxies, star clusters, and planetary systems. As space experts continue to examine this exceptional star, they will acquire new insights into the essential cycles that govern the universe. The lessons gained from Betelgeuse will shape our understanding of grandiose development for years to come. As Betelgeuse proceeds on its transformative path and shows surprising behavior, space experts will intensify their observational efforts. These investigations won't just further our understanding of this specific star, but will also contribute to the broader field of heavenly development. The use of advanced telescopes, like the Hubble Space Telescope, alongside other refined observatories, will be pivotal in providing real-time data on the star's behavior. These tools allow astronomers to gather valuable insights into the mechanisms behind Betelgeuse's change and develop more refined models of heavenly dynamics. By closely monitoring Betelgeuse, researchers will be able to make predictions about other stars in similar phases of their life cycle. The understanding gained from studying the processes that lead to the death of such massive stars is crucial to understanding the ultimate fate of other stars in the universe. Moreover, Betelgeuse's fluctuations in brightness, mass loss, and atmospheric changes provide crucial clues to the intricate forces at work in stars of this size. The investigation of red supergiants like Betelgeuse not only uncovers the internal workings of these stars, but also sheds light on the broader role these stars play in the grandiose cycle. Red supergiants are essential in the creation of heavy elements, which are crucial for the development of planets and life. The inevitable explosion of a red supergiant in a supernova releases these elements into the universe, enriching the interstellar medium and contributing to the formation of new stars, planets, and possibly even life forms. The material expelled during these explosive events is the building block of future generations of stars and planets, making the study of such events vital to understanding the pattern of cosmic creation and destruction. Understanding the role of supernovae in the universe's grand cycle also has significant implications for our understanding of the universe. The shock waves created by supernovae are known to compress nearby gas clouds, triggering the formation of new stars. These shock waves and the intense radiation from the explosion can influence the chemical composition of nearby stars and planets, thereby affecting the overall development of worlds and star systems. By studying Betelgeuse and other stars like it, space experts are gaining insights into how these astronomical events contribute to the formation and development of galaxies, star systems, and planetary conditions. In the case of Betelgeuse, the potential for a cosmic explosion offers an exciting opportunity for researchers to witness one of the universe's most dramatic events. If the star were to explode, it would release an immense amount of energy visible from Earth, even during the day. This would provide astronomers with a rare chance to study the final stages of a star's life, gaining valuable information about the processes leading to its violent end. Although such an event would pose no immediate danger to Earth due to Betelgeuse's immense distance, the explosion would offer a once-in-a-lifetime opportunity to witness a supernova up close, shedding light on the mysteries of heavenly death and, moreover, the broader vast cycle. The dimming of Betelgeuse recently has raised significant questions about the star's future, and subsequent speculations about its potential for a cosmic explosion have sparked intense scientific inquiry. Whether this dimming is indicative of an impending explosion or is part of a different, less dramatic phenomenon remains uncertain. However, the ongoing study of Betelgeuse provides essential insights into the behavior of red supergiants and the cycles that lead to their potential demise. As we continue to monitor the star's development, researchers hope to refine their understanding of how massive stars evolve and what signs may indicate the looming death of a star, including those that could lead to supernova explosions. Through continuous observation and study, Betelgeuse will remain a valuable reference point for astronomers studying other stars in similar stages of development. By comparing Betelgeuse's behavior with that of other red supergiants, researchers will be able to refine their models of heavenly behavior and better understand the